Hi, welcome to Fun Pub Videos. This is DC here. In this video, I'm going to show you how to use the Texas Instrument Tagit HFI Plus AS15693 tag using the PN5180 board. Now, I've already spoken about these tags maybe a year and a half ago. Now, I would advise you to see my previous videos on iCode SLI, because most of the concept, I would say 80% of what we have done in iCode SLI will also work with this Tagit as well. Now, if you want to know more about in general IS15693, I've got around 10 videos which have shown or gone through some of the concepts of 15693. So if you see my old videos, I have already used this particular tag, but that time I was using a reader from OmniKey, which is a 5431 reader. But in this video I'll be using the P5180 board. Now these are some of the important features of this particular tag. The manufacturer code is 07. So by this time, in order to send any custom commands, you have to know the manufacturer code, and the manufacturer code is always present in the UID of the tag. Now this tag has got 64 blocks with the 4 bytes in each block. These are some of the standard things you will see in all the IS15693 tags. Supports locks, supports AFI, DSFID. This also supports what's called a manufacturer lock, and again you have to refer to the data sheet. Now this is, to put in simple words, you can get the locking done during the time of fabrication. If you want hundreds of thousands of tags, and you can get the tags configured at the time of manufacturing itself. Now this important difference between this one and the one we already seen, the SLI, iCode SLI tag. All write operations require the option flag set. Now the option flag is a very important concept in this standard. I'm going to have a separate video about only about an option flag. But in this video, just keep in mind, in order to do any write operation, it could be locking, or in general, if you want to make any changes to the tag, you must have the option flag set. Say for example, during writing and locking of the data, during the writing or locking of AFI, during the writing and locking of DSFID, you have to have the option flag set to 1. But you have seen the option flag set to 1 before during the read operation as well, which I have covered in detail in my previous video. This tag still doesn't support any password, but there are other version of Tagit which does have the password. This tag has got 2 custom commands in 2 different modes. That's writing and locking 2 blocks at a time. So you can think about this like writing faster. Rather than writing 1 block at a time, you can write 2 blocks at a time. So please have a copy of the datasheet. If you visit my video channel on YouTube, this is the playlist that has got everything I've done so far on IS15693. You have to refer to this video, which is titled the Tagit HFI Plus IS15693 tag. This was done on 2018 January. So even this video has become like a reference video for me. Now if you remember, I mentioned about the option flag being set during the write and the lock operation. Even the standard document explains about this option flag. So if you look at an example of the write command, now we have seen the option flag not being set in the SLI icode SLI tag. But here the documentation says when the option flag is set, the wick, that's the tag, will wait for the reception of 100% modulated EOF. Now, so the tag will not respond until unless a EOF command is sent. So this is like the write operation happening in two steps. So in the first step, the reader sends the write command with the data. So the tag does not respond immediately. The reader again sends one more command that is just like an empty command called EOF, the end of frame command. Only then the tag responds with the response, whether the write is successful or not. Again, I'm not very sure at this point of time what's the main purpose of having the option flag set to 1. Probably, as I now come to know, I will let you know as well. So I always keep the data sheet of P5180 and the standard, as well as whichever tag I'm working on, ready with me. Now this is the document you can get from internet, and this is the table of all the commands that are supported by the Target HF1+. Now this document also speaks about two other types of tags. That's the HF Pro and HF Standard. So I could not make videos because I just cannot get any tags that are HF Standard and HF Pro Plus. If you have got any spare tag, now probably you can let me know, and we'll arrange to you can send that across to me, then I can put that in the video. So the most important thing here is the option flag. Now take an example of the write single block. The write single block, some of the things like you can send the write in the address mode, in the non-address mode, and in the select mode. And we have seen the addressed and non-addressed mode in my video on iCode SLI. I'm going to speak about probably select mode in this video, and the option flag is always set to 1. If you come across an entry like this where it says 0 or 1, it means this particular command can be run with option flag either 0 or a 1. We have seen this in my previous videos. Likewise, take an example of the lock block command. Here also you have to have the option flag set to 1. Likewise, commands like the write AFI, lock AFI, write DSFID, lock DSFID, all these commands where option flag have to be 1, they all refers to some kind of a change operation in the tag, say the locking or reading, also locking or writing. Now I mentioned about the custom tags. So this particular tag supports two custom tags. One is write 2 blocks and the lock 2 blocks, which I'm going to show in this video. And here also you have to have the option flag set to 1. Now this the background. This is like what we have heard so far is just the theory. So I'm going to show you all these features on one of the I got a brand new the target tag, and let's see how all this theory fits in there. So I've connected my PN5180 board with Arduino, and the version of the software I'm using is 2.2.1, and if you see the release notes now, so nothing major has changed since my last video. So I'm going to connect, and I'm going to use this brand new the Target H1+. Now choose this IS15693. Now as we did before, set this RF on, activate. Now as soon as it's activated, you can see a new tab has come here, like it's called Target. Now this has got the custom commands. So first you're going to hit this get to read the system information, and all the commands that's going on you can see here. Probably I'll spend in my next video I'm going to explain the various commands. So here it says there are 64 blocks. If I go on hit, now we have been doing this in my previous video with iCodeSL as well. So that shows all these commands, they work across various tags, and there is no lock information yet. Now because this is a brand new tag, all these data blocks are set to 0. That could be the manufacturer's default settings, and we have seen this get multiple block security status as well. If you hit that, so this reads all the lock information from all the 64 bytes. Now the reading and writing, they're all very straightforward, which I already done in my previous videos. So just to make this video interesting, I'm going to show all these operations once. Now here, when you get the system information from the tag, so this is the decoding of the information. It says the manufacturer code is 07 and the tag type is 00. 00 means this is a HFI plus. Probably I should have shown a description here. So these are the various flags. Remember, to do the write operation, you have to set this to 1. Now, so the read is done. I'm going to write. So just going to write this as take for example, I'm going to go in ASCII mode. So write, say, A, B, C and D. So go back to the hex mode. Now I'm going to write. Now let's see what is going to happen if I don't have this option flag set. So if you try to write W here, so it says the write failed, and you can see here the error code is 03. And if you see the data sheet or the documentation of this tag, you will come to know what is this 03 error means. So now the write did not work. Next I'm going to set this option flag to 1. So if I hit the write, now you got the write block. Okay. Now if you look at this command structure, now if you come across, if you see this EOF along with the command, it means the software is sending the EOF frame in order to receive the response. So here, if you ignore this A2, this is the command code sent to the Arduino program. Everything from this point on is the command. So this is the flag, this is the 21 is for write command, and this is the block we are writing, and this is the bytes we are writing. So that's the write is simple. So next I'm going to show you how to use this write 2 blocks and lock 2 blocks. So as this command says, you can write 2 blocks at a time and lock 2 blocks at a time. Now I'm going to bring all the lock bytes by using this ISO command called get multiple block security status. Now I have already locked these 2 blocks. So now in order to lock, and keep one thing in mind, locking, you can't undo it. So I'm going to put some default data here. So for example, I'm going to have, say, go to the ASCII mode. So continue with the E, F, G and H. So I'm happy with these 2 blocks, and I want to lock, I'm happy with these 2 data blocks, and I want to write. Probably you can modify if you want. Now if you hit, I'm going to set the start block as 0, and I'm going to hit write. So what I'm trying to do here is write the content of block 0 and the next block 1. So hit this thing. Before you hit that, make sure you have to have this option flag set, because all modifications can happen only when the option flag is set to 1. Now I'm going to say write. Now we got a write success message here, and if you see the command structure, so this is the command you can see, but if you look at the documentation, so you cannot make out exactly the command structure of custom commands for tag it tags. the document what I have doesn't show anything about that. Probably there could be some other document. However, it's not that difficult to come up with or to find the correct command structure of any custom command. See the standard document. Any custom command must have the following structure. It must have the flags, the custom bits. This is the custom command code. This is followed by the manufacturer code. This is followed by any parameters here for the command parameters. So is exactly to follow the same with the same structure here. So you got the flags followed by the custom command A2 for locking for writing, sorry, 2 blocks, followed by the manufacturer code, followed by all the parameters. So here the parameters are the block number, the starting block number, followed by the 8 bytes of data. So you can keep on trying that. Assume that I want to change the structure of I'm going to write something to block 2 and block 3. Now again you're going to choose what the starting block. It's a block 2. So from here, block 2, block 3 get returned if I click write. Now write is successful. Now you can see that the same commands, similar command structure, whereas the starting block here is number 2. Now what I noticed here somehow, which is not mentioned in the documentation as well. Now here the document doesn't tell anything about the what kind of address is that, but however what I noticed is if you try to choose a start block which is an odd numbered address, the write operation fails. Now I'm going to choose the start block as 1 in theory. So what this should be doing is write the block 1 and block 2. So however I'm going to say, let's see what's going to happen. If we say write, the write failed. I'm not very sure why. It is quite possible that somewhere in some of the documentation there could be some information that says the address, that is the start block number that is passed to the write 2 blocks and lock 2 blocks, must always be an even number. So it's nothing, we're not going to lose anything. You just have to now follow this this structure. Then nothing can be done if the start block must be an even number. So here again you got a failure. Again the error code is A1. So this is the custom error code, and we have to see the data sheet and find out what the error code is. I'm going to go back. So instead of 1 I'm going to choose 2 and say write. Now write is successful. So keep in mind, when you do this writing 2 blocks operation, make sure the start block is 2. Probably now I could have avoided choosing a odd number here. So I'm still not very sure whether this is the constraints or it's something wrong with the way we have done the coding in PN5180. Okay, so likewise the next thing about locking 2 blocks. Now I'm going to lock these two. I'm going to lock all the 4 blocks. Now I can do one at a time. So I can go and lock here, which is something we did in iCode SLI. But keep in mind, in order to lock you must have the option bit set to 1. Now what happens if the option bit is not set to 1? Okay, now if we try to write, now this is the software. This software is telling you to keep this option flag set to 1, but I have seen the write operation will not takes place when option flag is set to 1. So I'm going to show you, just to complete this tutorial on this target, I'm going to lock using just a standard lock here. So put lock. Now the lock is done, and to refresh here, read it. When you read operation is happening with option flag set to 1. So we have seen this in iCode SLI videos. When option flag is set to 1, the read operation will return 5 bytes, where the first byte is the lock byte, which is 0 1. That says it's the locked one. Now I'm going to use the lock 2 bytes to lock 2 and 3. Remember, you cannot lock if you want to lock this block 1, you have to use this single lock operation. So this is also locked, and refresh. This is done. Now I'm going to use this lock 2 blocks command. So I'm going to choose from block 2, I'm going to lock. There's a warning here that says it's a one-way operation. Now it's successful. The command structure, again, this is A3. A3 is, so here it starts from the flag. Then if you see the flag that matches the number what you see here, there are only 2 flags that are set, followed by A3. A3 is the command for lock 2 blocks. If you go here, so this is A3. That's followed by 07 is the manufacturer code, which you see here in the system information, followed by the address, the start address, start block number, which is 2. So all these things, okay, if you want to refresh, it's done. Refresh here, it's locked here, locked, okay. The same thing can also be done in the address mode as well. Now if you go back to this command structure, now this command write to and lock to works in the address mode, in the non-address mode. What we have seen so far is the non-address mode. It also works with the select mode. I'm going to show you in the address mode, and when I'm going to make a video on the select and stay quiet and other things in a video, I'm going to explain how these things will work with the select mode. Now in order to do with the address mode, so let's go and write something to block 4 onwards. So I'm going to use 4 for, okay. So here this time, if we want to address mode, you have to keep on in mind whether there's address or non-address or select mode, you must always have the option flag set to 1. Now choose this address mode. So I'm going to clear this logs, and I'm going to write everything starting from block 4 and block 5. So I'm going to set this as a block 4 and say write. Now the write is successful. You will see the difference in the command structure. So the command structure, again, you have to follow this exactly the same order. You'll have the flag followed by A2 for write 2 blocks, followed by manufacturer code, followed by this is the data, sorry, this is not the data, sorry, followed by UID. So this is the UID because it's in address mode. Every command carries the UID of the tag. From here to here, it's a UID followed by the starting block, followed by the 8 bytes of data. So that's successful. So I can use the same thing, should work with the lock as well. So lock write. Now we just locked 2 blocks, that's block 4 and 5. Again, here the only difference here is, now if you compare this with the previous command, you got the A3 is the same, the flag is different, which is 62, which includes the addressed flag as well, and you got this is the UID of the tag followed by the block number. So only thing missing is the data. We are not writing, we are just locking the data. Now you also have got, so you can also lock AFI and DSFID. So again, keep in mind you can't undo this thing. Probably at the end of this video I'm going to probably bin this tag, because I'm going to lock everything here. It becomes literally like unusable for my future videos. So I'm going to do this thing without a flag, without the option flag, and going to see let's see what's going to happen. I want to set the AFI of the tag to say 05 and set. Now AFI write is failed. The reason is, it's because, so you got the 03 command, and probably you can see what the 03 error is if you go to the standard document here. So if you search for the error tags, so the standard says when the error code is 03, the option is not supported. So it's just a very vague error message. Okay, so I'm going to select this option flag, and I'm going to set. Now AFI is successful. Now there is no way you can, if you see the command structure here, it's all the same basic command. There's no change except the flag. Now there's no command to read the AFI. The only way to read is the best thing, close this thing, come back, so activate, go to the system, get, you can see the AFI is this. Likewise, I'm also going to do say 06, and before you set, I'm going to have, probably this time I'm going to use the address as well. So we're going to write in address mode. So set. So I'm not sure whether this works without bringing the data, but let's give it a try. I'm going to set. Now write is successful, and you can see this is a longer command now, because you also have got the UID because we're using address mode, and we're going to set the value to 06. Now this is the command structure for write DSF ID with option flag set to 1. So I'm going to bring, you can try reading with both option and address mode. Let's see what's going to happen. Because I've got only one tag here, I don't need to use the address mode. It's just sending more information to the board, but still it works. So the next thing is the lock. So in order to lock, again this must be, so if you try to lock without this option flag, now again you should get an error. Say lock error, because the error code is 03. Now I'm going to set this thing and lock. Now lock is successful. I'm going to lock this as well. Lock is successful. Now with this, if I try to modify and set, now set gives error because the DSF ID AFI is already locked. I think that covers, probably we have covered most everything about this tag it HF1 plus. So in my next video, I'm going to cover how to use the stake white and reset to read and select and EOF thing. Thanks for watching.